Welcome to the CSBP Fertilisers Grow Better Podcast, sharing knowledge with growers on leading crop nutrition, sustainable agriculture and other issues impacting the agricultural industry.
G'day everyone, welcome to another episode of the CSBP Grow Better Podcast. My name's Johnston and I'm delighted to be joined today by Emerita Professor at the UWA Institute of Agriculture, Lynette Abbott. G'day Lynn.
G'day, thanks for having me.
Oh look, it's our absolute pleasure, and we're looking to talking all things soil health and learning about you, your research interests and your career today. But as is our custom on the show, please can you, for our listeners and viewers, introduce yourself and put all that in your own words.
Well, I'm Lynette Abbott, actually Lynette Abbott. But
excuse me.
Most people, most people call me Lynn, so, and that's what I remember myself as too. So I'm at UWA. I've been at UWA for the whole of my career. I came to Perth in 1974 and accidentally fell into a position at UWA, and I have been there ever since. So I've started out in research and then moved into teaching and after about 10, 11 years. So I've had a teaching and research career at UWA and retired as a professor in 2013.
And the focus of that over the journey has been soil or?
Well, I started out as a plant person and then I became a soil person because plants grow in soil. So I ended up here working on mycorrhizal fungi, which was funded by the Australian Wool Corporation, as it was called then, so the wool industry, and they were interested in pastures. So for some reason many years ago, I was lucky enough to get a postdoc at UWA, and that's what I started my research career in, really, after PhD, which was on plant pathology. But mycorrhizas are symbiotic organisms, so you have this interaction between the plant and the fungus, and that's been really interesting to me to have a look at an interaction rather just a single entity, and I've maintained that interest.
So you retired as a professor in 2013, and you've clearly had a long and varied career. I guess, can you tell us a little bit more about where the passion for soil health and plants came from?
Well, initially I was interested in plants, and that's what I went to university to study. But because plants grow in soil, I ended up in my next phase working on root pathology, so disease of roots, wheat roots. And then when I came to Western Australia in 1974, I got a position that was funded by the Australian Wool Corporation to work on mycorrhizal fungi. Now, these are fungi that occur in all soils and they infect or colonise the roots of most plants, so they're beneficial mostly. But the story was they help in the efficiency of nutrient uptake in those days. But now we know that they do a lot more things. They help in soil structure and water uptake, all sorts of things. But at that point, I was doing research on these fungi, and then I got a teaching position at UWA, and then I had to teach soil biology. Then I broadened out into the broad base of soil biology. But interestingly, at that time, which was a long time ago, the general understanding of the role of soil biology wasn't incorporated much in agricultural practice except for rhizobium. So, of course, we understood that rhizobium was important for nitrogen fixation of legumes and we inoculated our plants. But all the other organisms in soil were just doing their thing without having a very specific focus. So there was no talk of soil health in those days. In fact, the scientists said, oh, you can't use that word, it doesn't mean anything. And then gradually the idea of what a healthy soil evolved and people were more interested in the biological component of the system.
And I reckon that word you finished with there, system, I mean, I've worked in agriculture now only for a couple of years, but it feels like the need to think in systems is ever present, and everyone is continually advancing in their understanding that we need to be thinking in systems and that you pull one lever and it can impact a whole bunch of different things. And I guess that's then how we get to this concept of soil health.
Yes.
Can you tell us what we mean by that soil health?
Well, soil health. So I used to think about soil fertility because many years ago that was what people used to use as a common word. But the problem with soil fertility is that it has a focus just on nutrients or physical. It doesn't sort of have a biological word attached to it. And so that's really what I explored a lot in my career. to think more about biological fertility as well as chemical fertility and physical fertility. So you've ended up with a situation where you've got these three components, physical, chemical and biological, and in combination, just like in human health, we have those components, and in soil, we have those components for soil health. But they're not easy to untangle because the biology is also related to the chemistry because the nutrient cycling affects the nutrients. The biology affects the nutrient cycling. And then the biology also affects the physics, affects the structure of soil and how the particles stick together, all of that in aggregation. So you can't just separate it as this and this bit and this bit, and that is it is a system. And I think, interestingly, farmers are used to thinking about systems, and this is just a smaller scale of soil system.
And I guess the way you described it there, I was just thinking, next to pop science books about the microbiome and people's guts, probably pop science books about soil and soil systems have been, pretty flying off the bookshelves in the last couple of years. Do you think, and there's been a few that have come out.
There's a lot of interest.
Did you think your career's just come slightly at the wrong time? I mean, or you would say you're a pioneer in getting all this interest happening?
I think I like a challenge, actually. And so I was
You mean you've got a pop science book in you?
No. I'm writing a book, actually.
Oh, there we go.
But the idea of working on what we already know doesn't provide the challenge. I think working on something that's a bit tough is better. And it was just happened that I was working on soil biology when it wasn't the flavour of agriculture. And, that also, it's been a challenge for me to work out how, especially when we're teaching students about soil biology, but it's not a major part of the next phase in their career, perhaps, except in special cases, of course. So the idea of working on something that needs more explanation of how it fits. I'm not saying people didn't know about soil biology. The literature is littered with wonderful understanding of soil biology, but it's that taking that information and applying it in our agricultural production systems, that's the bit that's a bit harder because we're very good at understanding nutrients and how we need to apply them to particular plants and cultivars. We know all that very well. It's then how do you let this biological base do what it can do so that you get that holistic benefit, which is really the healthy soil part of it.
And so you must have a good understanding and you take a good look at the production systems in WA. I'm sure there are a lot of people listening and watching this podcast who are screaming out, okay, Lynn, you've posed us a question there. What's the answer? What are the big things we should be focused on in WA production systems to focus on soil health and soil biology?
Yeah. Well, it's not black and white. It's if you've got phosphorus deficiency, you know what to do about it. You can deal with it.
Call CSBP.
You do, exactly. And you do the soil testing, and that's all very, very well set out. But if you want to use a biological component in that as well, it's just a little bit harder to fit that together. It's not, here's the recipe, do this. And the other thing is that building the biological base of soil health takes time. You can't just put it on. You can't apply it as an inoculant. You can't just put it in. You can do that. You can add rhizobium because that's very specific. But most of the other organisms in soil are in a community. They're not just a single thing doing their own thing. So you can't just put some in. That doesn't work. So you have to provide the environment for it to grow in a way that it can contribute. And that means that over time, you might get something building up in this interaction between the physics and the biology and the chemistry and the biology. But you can also destroy it very quickly. So a management practice that interrupted that could then set you back. So it's sort of a bit more precarious, but it's getting to a better place. So you've got this challenge of dealing with the economics of running a farm, which is really the priority here, and then trying to build the soils to a better space. And sometimes you can't do it as fast as you want to do it.
So management practices like no-till, widespread adoption of no-till have been adopted in the time you've been looking at WA?
Yes, and that was wonderful because it put, when I came here, soils were blowing. The south coast sands were blowing everywhere. So there was a lot of wind erosion, water erosion. So the no-till was a turning point. And it was an innovation by farmers who looked at, they're innovative. They're looking for these questions themselves, answers themselves. So no-till was a very good benchmark here. We just came ahead from that. But it's not everything, because it depends on a lot of inputs, and so it doesn't always build the biology in the way we might like it. But it's a starting point. It's a very important starting point. And it deals with the physics as well as the chemistry and biology. So you've got that baseline, and then what can you do on top of that? Well, that's the question, really.
No, but that's the question. I mean, that's the question we'd love you to have a go at for us, at least. Are there particular management practices you see as big opportunities?
Well, if you want the biology, the organisms in soil to work, then you have to provide them with an environment where they can work. So that's a bottom line. And so primarily, most of the organisms in soil need carbon. Not all of them, but they get carbon from... They can get carbon from, a few of them can get carbon from CO2, but most of them get carbon from organic matter. So that's a start. And no-till will keep the carbon, so that's the beginning bit. So then, but you're providing an environment where they can function the way that they would prefer to. They don't have a mind, but that you can imagine that if their conditions aren't right, they're not going to function much, or they won't multiply up. So then you've got this question, well, no-till's good because it puts the organic matter in, but then what's the layer on top of that? Now, this comes back to the question of measuring things in soil and doing soil tests, and CSBP is the big person in that one. But soil biology tests are very more variable than chemistry tests. So I think that the point is that farmers know their own soil. They know their own conditions. They know their own farm, and they know it better than anyone else. So they are walking around all the time or driving tractor or whatever. So I think the point of building a biological base depends a lot on the farmer and their own inputs and ideas and thinking about how they could protect and build the biology. And there are a lot of innovative people out there at the moment doing all sorts of things. So I think that to build this biology, it depends a lot on the farmer, making decisions around the inputs that they have available, and they are nutrients, of course. There are a lot of other nutrients, not a lot of other inputs they can put in, but the idea of just running something on nutrients, I'm saying this to CSBP, is not sufficient probably to make it all work. So something has to be put in there as well.
And what about things like rotations? Because
of course,
a lot of decision making still is made on annual choices on rotation based on commodity price conditions, and of course we know that a lot of growers are adopting longer and longer term rotational plans that look through that season, and we see it through trying to plan nutritional plans that will support those rotational plans. I assume that is the type of management practice you're talking about.
See, and it takes me back to when I came here, and I was funded by the wool industry, so there were a lot more pastures, and keeping living plants in the soil is a good thing for building biological processes. So you've got a situation where we've moved into rotation with canola, wheat, and these are systems that on the whole don't support building up of, in the same way they don't support building soil carbon, they don't support building microbial communities at the level that you would probably want them to function. So that's the decision making, and I'm very aware that farming is a business, and so the idea of linking the economics to some of these biological processes is something we're doing research on at the moment. And the idea here is that if you make this decision, or if you decide to try and build biology in one way or another, what's the cost? And then that goes back to the farmer to make decisions. But things can change. So you could have certain decisions going along for a little while, and then you can make another decision. So you can go up and down. But I think that's what's quite interesting about soil biology, that you can knock it back quite hard with some decisions, but then you can build it back up, although it can take some time. So it's not the end of the world if you, at some point in time, don't have as much biology as you might like. But that might be run at one level of economic level. But if you keep doing that, then you'll end up with soil degradation. But we don't want that.
You mentioned soil organic carbon, and it's been a focus of a number of industry stakeholders, government, particular ag ministers. Do you have a particular take on it? And we hear a broad range of perspectives as it relates to WA soils, their capacity to develop carbon. You've talked about the importance of some carbon in the soil to maintain plant biological matter and keep living things in the soil. Can you give us a bit of your perspective on soil organic carbon and the WA story?
Well, I'm not a carbon expert, but I am interested in organisms and they depend on carbon. So there are fungi that we've worked on, the mycorrhizal fungi included, which can have a role in helping to influence soil structure, so beneficially. So soil needs to form aggregates so that you end up with pores and air and moisture around. And so the fungi have an important role in soil aggregation, and that's what we've done research on. That's very minute scale, but at the same time, and this was years ago, we were doing some of this work, it wasn't in the context of retaining soil carbon, but as people understood things more, they realised that the best way to keep carbon in soil was really to protect it from the microbes. So here you've got microbes, you think, oh, let's have lots, they're good, but also they can chew up carbon. So the idea of structure is so important, and having good soil structure and protecting carbon is key. So that's the bit that I'm interested in, but there are many experts in carbon. But the particular ideas around the role of the fungi, where I've had more of an interest, I think.
But you talked, I guess, in the answer to both of the last couple of questions, you talked about carbon as an output and an input to the system, which incorporates a crop rotation, economics, global commodities, the season, and the grower making decisions to balance all of those things for the short term and the long term. Is there then, which is I think probably the way that most of the listeners to this show will see it as well. Is there any prospect of WA soils becoming a massive carbon sink and offsetting carbon emissions from the rest of the economy?
I won't do the sums on that one, because I suppose my focus is to protect soil, and that's the big thing about where I've come from, where soil was not really thought to be that important some time ago, and now it's seen to be very important. So protecting the soil base is, if you do that, you will then lead to these other issues of the carbon story, because someone will come from the carbon side, I'll come from the soil organism side. But it's interesting that some people think, oh, you need lots of organisms in soil, but having lots of organisms in soil will also chew up all the carbon. So it's understanding what's going on that is where I sit, really, because someone else can do the calculations, but clearly if there's organic matter that's being incorporated in the soil and it's readily accessible to these organisms, it'll disappear. It's simple.
So there's a lot of work that has been done. It sounds like the knowledge of the industry and the importance of systems thinking across not just chemistry, but physics, chemistry and biology of soil have improved markedly over the course of your career, and probably influenced by that. What's the next step? Where are we heading? And because it also feels from the interactions we have with farmers and researchers across WA that those concepts are really now well understood, and people are managing the soil better and better.
People are aware of it, and it's a major consideration.
Yeah, but you're still out there getting funding for research projects. So I want to know, what's next, and what are your PhD students focused on, and what do what are the next 10, 20, 30 years going to bring?
In the last year or so, we got a grant from the Australian government, which was part of a Soil Science Challenge program, which is a one-off program to fund mechanistic research on soil biology, I I expect.
What does that mean? If it just help us for...
The mechanistic that's where I think is understanding how something's working. So you can
understand what's happening.
You can say what's happening,
Yep.
but why? And
Yep.
that's really what research is about, the why. And so this is a program at UWA we have, and it's joint with the University of Adelaide and Western Sydney University. And it's focused mainly on soil amendments, so biological amendments. So these are we're not putting compost everywhere, but we're using strategic use of some inputs and then thinking how the organisms can, or how the soil can function in the presence of these inputs, but also in relation to combining these inputs with conventional type fertilisers, mixtures. So amending the amendments and adding clay, all sorts of things. So amending that space, the nutrient supply space. Now, I'm talking in Western Australia, where often in sandy soils, but in the other two states where this is being investigated, they don't have sandy soils. So I think what's good about working in sandy soils is because it's so tough to get these processes working, it makes you ask questions that people in a good soil they don't think about them. And I think that's what I found over the years, that the WA situation, where it's such a challenging, highly weathered soils, has provided a way of asking questions about soil biology, which other people don't think about because it's not relevant.
And this research is particularly for soils to support dryland cropping systems?
Yes, and well, we work across crops and pastures,
yep.
and so it's both. But it's fundamental. It's looking at mechanisms, as I said, how something's working, and at the level of fungi and bacteria. Now, there's a lot of interest in fungal bacterial ratios these days among the farming community, and we're looking into that as part of this. But that's more a role of the fungi than the bacteria.
And what sort of amendments or inputs are you talking about?
Well, they're mainly composts of various kinds, but also digestate out of an anaerobic digester, which it's using waste materials that have an organic base. But again, it's looking at examples of these. So not comparing everything that's around, but looking at types of interactions that occur at that fine scale when you have chemical nutrients next to these biological products and how they interact, and what are the fungi and the bacteria doing.
It sounds like fascinating work, and I'm sure we'll be interested to see what the outputs are. We talked about no-till, you talked about soil amendments there. I guess I'm interested also in, and you talked about the sandy soils of WA, another trend that's probably a bit more of a recent trend is the vast scale of soil amelioration that's happening in the state. Is that something you also have an interest in or have observed happen over the last maybe closer to 10 years?
Seen that happening, and I think it's one of the issues here is how fast can you, or how long can you wait for some beneficial biological process to happen? And I think that's what is a problem here, that if you just wait for biology to restore a soil that's degraded, then you might be waiting a long time. But some of these bigger remediation processes that are going on quite a scale, they can fast track that. So I think it's a combination, because a lot of these soils have been under agriculture for a reasonable amount of time in WA. And so you've got a history of impacts of those practices. So just to think the organisms are going to fix all this instantaneously, it's probably not realistic.
Good to hear, and you've shared a very balanced view on a lot of things in this discussion. Anything else we should be looking out for in the future? What are the next set of buzzwords going to be?
One area that I think that does involve microbes is an area that's of a lot of interest is biostimulants and biofertilisers, whatever these are. I mean, they're different definitions. But internationally, the biostimulant industry is going gangbusters. So there's interesting over my career that initially I was trying to raise awareness of soil biology and help people understand the soils, and we did all these workshops in the countryside and everything. But it's changed a bit now, because that's all sort of, the awareness is there. But now it's almost gone the other way, and some element of the situation now is that, we can fix it by adding microbes. And that's where I don't think the awareness is clearly there, because, you can try things, yes, and I think that's in the lap of the farmers. They can try things, but with awareness, because I think a lot of things that you can buy in bottles may not survive if you add them to soil, and that's well known. So you've got this conflict now where the awareness of soil biology is very strong, but also the impulse to want to add things to the soil, like mycorrhizal fungi, people want to add them all. Well, my idea is, why aren't there more now? And so how is our current practice influencing them? So there's money involved in buying inputs, and there's understanding required in making decisions. So that's where I think I've got a bit of a role. But definitely this area of biofertilisers and biostimulants, it's just going everywhere across the world, and probably less in Australia, but it'll come. And I think we've got a role in making people understand what's going on in that space as well.
And look, I think at CSBP, it's certainly something we're very cognizant of, and it's certainly something we're going to keep a very close eye on, because we certainly do our best to watch what's happening out there in research and what's happening in other countries. Yeah. There hasn't been a lot of adoption here in WA, as you say, but I think also that's why we think it's important to keep looking at the research and understanding the balanced view of people like yourself, because if it's not naturally there in the soil at the moment, is there a management practice that is stopping that, that's stopping it being there, and therefore is it not going to be a great use of grower money to apply that input? So look, a great, I think, point on which to wrap up our discussion, and it's been a really broad-ranging and lovely, balanced discussion. Heard about your career, heard about the focus of what you've been looking at, which is a nice reflection of what we've been focused on in the WA agriculture industry over the last 40 years. So thank you, Lynn, very much for joining us.
Thank you very much.
And thank you all out there in podcast world. This has, of course, been another episode of the CSBP Grow Better Podcast. You can follow what we're up to at CSBP Fertilisers by using the tag at CSBP Fertilisers on most of your social channels. And, of course, you can get in touch with your local account manager anytime to address any of your fertiliser or nutrition requirements. Till next time, I've been Gray Johnston. Thank you again, Lynette Abbott. See you all later. Bye-bye.
Thanks for tuning in to another episode of the CSBP Grow Better Podcast. For more information about CSBP, please visit csbp-fertilisers.com.au or connect with us on social media at CSBP Fertilisers on Facebook, Twitter, Instagram and LinkedIn.